So you might have heard about these new kinds of super-fast trains that run in Asia. They've primarily been used in Shanghai and the Tokyo areas, but even see applications here in the US. They're called maglev, magnetic levitation trains, but how do they work? Well, a traditional train works by burning some kind of fuel to heat water and create high-pressure steam. This steam enters the engine and causes a piston to move, which then turns the wheels. Although this design is simple and reliable, it creates a friction force that slows the train down and burns large amounts of fossil fuels that pollute the environment. By contrast, maglev trains go so fast because they don't have a friction force, since they're not touching the rails themselves. By running a strong current through the rail, something called Ampere's law creates a magnetic field around the track. Using this magnetic field, the train can repel itself from the track and levitate 1 to 10 centimeters on top of it. But how do the trains achieve this amazing feat? Well, you probably know that magnets of the same polarity repel each other, so the train and the rail act as superpowered magnets and repel. But why doesn't the train go flying off the rail or fall off? There's even a theorem that says that no paramagnetically magnetized body, the train, will find equilibrium with just permanent magnets. So how is it stable? Well, here come electromagnets to the rescue. Ampere's law describes how electric current creates magnetic fields. When a current is run through a wire or a rail, the moving charge creates a circular magnetic field around the rail. This magnetic field provides lift for the train, and since the current run through the rail is alternating current, there's no net push on the train from one side to the other. The net force is all upwards, resulting in a smooth levitation. Different maglev trains use different methods to propel themselves down the track. One such method is to use different polarity magnets along the sides of the track, such that the magnets in front of the train attract it, and the magnets behind the train repel it forwards. To mimic the basics of what maglevs do at home, you can build your own levitating train with a few bar magnets. Begin with a long bar magnet and attach 2 strips of cardboard or wood along each end to keep our train moving at a specific path, like so. Then, just place a smaller magnet in the tracks so that the repulsive poles of the magnets face each other. You may notice that the magnet train is not very stable and relies on the cardboard guides to keep it moving along a path. This is why maglev trains use electromagnets, which allow for more control over the system and better stability. Unfortunately, maglev trains require currents that are a bit too dangerous to try out at home. But if you want to learn more about the trains, sources are listed in the description.